Good afternoon, Athens. I'm ZeroKPunk from Orbiter Finance. I'm so great to be here and to share our experience and our vision with you guys. Yeah. And Orbiter Finance is a decentralized cross-roller bridge initiated on the Ethereum. Our bridge security is inherited from Ethereum, and the cross-roller transaction is very fast for high capital utilization. And the gas fee for cross-roll-up transaction is theoretically lower bound. And because users just need to interact with an EOA address and no any extra gas overhead with other smart contracts. Yeah. In the last year, we just released our protocol of the decentralized Orbiter bridge. And our decentralized bridge protocol is with a ZK foolproof game, and the liquidity provider need to deposit enough margin on make a deposit contract, while the contract is deployed on Ethereum, and the transaction flow is divided into two parts for the correct process and the dispute resolution process. In the dispute resolution process, we need to validate the source transaction and the destination transaction of layer 2 on the Ethereum. And we use the ZK technical to implement the validation of layer 2's transaction on Ethereum, which is called the ZK SPV here. So what is the ZK SPV? First, let's go back to the at the SPV. SPV is for simplified payment verification. It was first appeared in Bitcoin white paper session A. And the SPV helps you validating the transaction on Bitcoin network without downloading the full blockchain data. So you don't need to set up a full node of Bitcoin network. If you want to validate the transaction about the TX3, sorry, this is the hash 3. I'm 1. Yep. And you just need to store the data of the corresponding block header and construct the Merkle proofs left by left, and that is the computation of a hash, right? And in our use case, we want to accurately validate layer 2's transaction on Ethereum. And let's recap how a layer 2 works on Ethereum. As you can see in this page, the word trial and the recipe trial and the transaction trial are maintained by layer 2 network. And these trees states are aggregated into some blocks, and the blocks are aggregated into some batches. And these batches are periodically submitted to Ethereum by layer 2 sequencer. So how do we validate the layer 2 transaction on Ethereum? And let's take an example of on a layer 2, let's send one ETH to blob, and we can retrieve the transaction by a hash data from layer 2 explorer. And as you can see there, the Bob's address is mapped to the field of the 2 address here. And the transfer amount of the 1 ETH is mapped to the field of value. Alice address is mapped to the field of VRS, that is the signature data. And the transfer success is, the status of the transfer success is mapped to the field of the status code. And yeah, Alice address is mapped to the, and so we can get the transaction hash and the recipe hash here. And then the transaction trial and the recipe trial finally get the batch hash. The batch hash is stored in the Ethereum. So we can, if we take the parameters in the green blocks on the as the public input and the middle part of the computation into the ZK circuit, and the corresponding proof of can be verified in the Ethereum for validating the transaction of, Bob success transferred 1 ETH to Alice on layer 2. Yeah. The ZKP in our product, the cost of the ZKP verification is only about 0.35 million, and the proof time is about 300 seconds. Yeah, so why we gonna upgrade from bridge to layer 2? Yeah, as we know, the layer 2 funds fragmentation, and we want to support more function for layer 2's interoperability. Yeah, because our bridge currently only supported the asset cross-chain. Yeah, and we want to enhance the UX for the user who want to play the game of the cross layer 2. Yeah, if you want to cross roll up, started a cross roll up transaction, and you need to switch the network RPC API in your MetaMask wallet. And this is the protocol stack of our Vizing. And on top of that, we have the Omni account abstraction. And when the user try to interact with layer 2 ecosystem, they don't need to switch their wallet network RPC. That is really annoying, right? And the Omni account abstractions can send cross-chain transactions through the universal cross-chain protocol here, and which support arbitrary messages cross-chain, and we will build and prove aggregation layer on the Vizing. And today I will talk more about the technical part about the proof aggregation layer, because this is a ZK event, right? So let's take a look back at about how we validate the proof on Ethereum. Actually, we often, the first phrase is the right circuit, and the second is solidity verifier. Yeah, and when we use the Circum ZK stack or the Halo2 KTG ZK stack, and they often offer the tools, and we deploy the verifier on the Ethereum, and we generate the circuit's proof, and we submit the proof to Ethereum. And the solidity verifier will validate this proof. Yeah, let's take a look about the overhead of proofs in the bull market. Yeah. And I'm going to talk about what kind of proof aggregation layer makes sense. And if you are a Halo2 KTG developer, it's very easy to aggregate the Halo2 KTG circuits by the Snack verifier. The tool is developed by the ESP Ethereum Foundation, and if we are growth 16 developer, and we can also have another tools to aggregate this proof. And if we have but what if our ecosystems have different kinds of ZKP system developer? So this is a very hardcore cryptography problem to combine all of these kind of ZKP system. Yeah, in our design principle, and we will support the aggregated verity sticky system proofs, and for the minimal inventiveness for ZK projects. And that is our new paradigm of the proof aggregation scheme. And our Vizing layer 2 will be a type 1 ZK EVM, and in our type 1 ZK EVM, and we will have a proof control contract on this, and the user just need to deploy their solidity verifier on the Vizing, and they just need to submit the proof to the verifier on the Vizing, and just like the rollup, how it works, and he will periodically submit his state roots on the Ethereum, the Vizing layer 2 contract, and we will have our another prover service. It's like the ZK SPV aggregator, and if the user submit a proof one, and it will have a transaction one, and the proof two, and he will have the transaction two, and the proof n, and he will have transaction n. So we will use our ZKP aggregator to prove the transaction of all of this, and we will aggregate it into the Merkle root. The Merkle root will be constrained by the ZK circuit, just like how ZK rollup works, and we will sync to the Merkle root to the Ethereum. Yeah. So if the user for the ZK developer, and there are only 4 phrases you need to do. And the first is you just need to deploy your solidity verifier to Vizing layer 2. And the second phrase is you submit your ZK proofs to your verifiers to Vizing. And number 3, the 3 phase is make a Merkle proof on Ethereum. The 4th is your proof is verified. It's so very simple. Yeah. Yeah. That's all I have to you, and thank you.
Thank you. Are there any questions about Vizing layer 2?
Hello, thanks a lot for the nice presentation. Can you just please make a kind of parallel comparison with respect to Polygon aggregation layer or many other, I mean, there are many other aggregation layers at the moment, but just let's state the most specific one that that is a kind of popular at the moment.
Yeah, our aggregation layer is just for will be very easy for the ZK developer. Yeah. And it's not for all kind of the layer 2's aggregation, and you just need to deploy your solidity verifier on the Vizing, and you just submit a proof to that, and your proof will be aggregated automatically. Yeah, that's the difference to them.
All right, thank you. Okay, thank you. I guess maybe it's quite different from like how Orbiter started with this ZK EVM, because you already have application there. So probably like you are aiming more to solve the interoperability problem?
Yes, yes.
As a bridge?
Yes.
Okay, cool. Thank you.